So moving on to corticospinal tracts. So these are descending motor tracts. So these control skeletal muscles. So they are motor tracts. So you've had the somatosensory tracts, which have gone up. So where the sense is coming in, the information's coming in. This is now, you've got the information and now something is going to happen. So it's descending, it's motor, something is going to happen with skeletal muscles. So this diagram is looks a lot more frightening than it actually is. And I'm just simplified it a tiny bit as well. So here at the top, this is your brain. And in your brain, you've got a whole bunch of motor neurons. So you've got two types of motor neurons. You've got BET cells and just your normal run-of-the-mill motor neurons. So the BET cells are these ones with the little triangular tops, right? So these are BET cells. And the thing with these is they're a bit quicker, they're more direct, because as you can see, it links directly to another motor neuron, which then which then goes to the skeletal muscle and you get a movement, right? So bump, bump, movement. So with a normal motor neuron, a couple of teas in the way, this is your motor neuron, and then it goes via an interneuron, then the next motor neuron, then the movement. So this is a normal motor neuron, but you can see it uses an interneuron. So all that means is it's a tiny bit slower. So BET cells and these regular run-of-the-mill motor neurons, they're all motor neurons, just that BET cells are more direct, slight bit, and a little bit quicker. Okay. So nothing too dramatic there. So we've got a mix. We've got a mix of BET cells and your run-of-the-mill motor neurons up here in your brain. So so these motor neurons, they come in from your cortex and they congregate at this red thing, which is your internal capsule, right? So we'll just, oh, I think that's the wrong coloured green, or is it? Nah, fucking hell thing. So they come in and they congregate. They all come in. Yeah, they've all been invited to the same party. They all come in. Oh, missed one there. They all congregate at the internal capsule. Okay? So, at the internal capsule, they descend in a big, thick bundle throughout the midbrain. So they come down through the midbrain, all right, in a big, thick bundle, all bundled together. Okay, they're sharing a taxi. They're all coming down, big, thick bundle down in the midbrain. Now, what happens when they get to the pons is that they spread out. So we can draw this a bit like that. So they spread out when they get to the pons, okay? And then they bundle back up again in the medulla, okay? So they bundle back up in the medulla, and then in the lower part of the medulla, they decussate. So they cross over to the other side. They decussate. All right. And once they decussate, they continue down the spinal cord. And we shall draw that thus. Okay. And so they decussate, they continue down the spinal cord, and then they will synapse with the appropriate motor neuron in order to take or to make an action. So, how am I going to draw this? So, say here in our cervical, I've got to draw this, try and draw this right now. So one comes off here, there, okay, and then you get a synapse, which we shall draw. Boop, boop, boop. Okay, synapse. And then that heads out boom, in order to make a muscle contraction. And in the meantime, this continues down. Yeah, and I don't know why that's a dotted line actually. It doesn't need to be a dotted line. Continues down and the same again. So we can have another action taking place here. I've not drawn that best, but you know, such is, and then it comes out, whoop, and then that makes another action. So that goes to the muscle, and so does that, and wherever it is on the path. So what else have we got? So that happens. So if you should have a lesion in the cortex, somewhere in the cortex, that's going to have very specific consequences because they're all separate up here. So have a lesion somewhere in there, it's going to affect a single one of these bad boys, single motor neuron, and it's going to have a very specific consequence. Where it bundles up after the internal capsule, bundles up. If you have a lesion in here, now that's going to have quite a global effect because they're all bundled up, and that's going to cause a lot of disorder. If you have a lesion in there, that's going to affect a whole bunch of stuff rather than just the one up here. So it's going to be quite a global effect. If you have a lesion in the pons, somewhere around in the pons, it's going to be medium specific because these fibers have spread out, because they're spread. So say your lesion is here. These ones are intact, but these ones are not. So there's going to be an effect, but it will be medium specific. Okay. And if we continue down, if we come down here, for example, and we get a lesion in at the level of T6, so you would have issues, motor thoracic issues, motor issues. What am I talking about? You're going to have motor issues at the level of T6 and below. Likewise, if you should get a lesion at L5, everything above that lesion would be fine. But at the level of L5 and below, there will be motor issues on that side, on the same side, because it's already decussated. So it would be the same side that you would get those issues on if there was lesions somewhere along the spinal cord. So you'd get it at that particular level and below. I think that just about covers that. Yeah, there we go. And that is your corticospinal tract, descending motor tracts.